Hello everyone, my name is Jorge Isaac and my teammate is Isaac Ramirez. Today we are exploring chapter 6, Colorspaces, Transformations and Thresholding. In this section, we advance from simply displaying image to actively extracting specific features from our visual data. So first, we isolate an object based on its color instead of using the standard RGB format, which is highly sensitive to shadows and lighting changes. We converted the live video feed into the HSB color space, hue, saturation, and value by defining a specific mathematical range for the color blue. We generate a binary mask. We then apply a bitwise AND operation which acts as a digital filter. It lets only the blue pixels pass through while turning the entire background completely back. This is the first step in object tracking. So let's see how it works with the camera. So this is the object mask, and here we have our original video. So as you can see, we defined that blue is showing, so it's a little bit of lag, but as you can appreciate, only in parts blue there are illuminated. So for example here, let me zoom it more, a little more. So you can see here. Uh, so this is the first example for our color HSB. So let's continue with the next one. Let me stop this and go to the next one. So next we apply geometric transformations to a static matrix. We use mathematical interpolation to scale an image down to half its size. Then we calculate its absolute center and generate a fine transformation matrix to rotate the image exactly 45 degrees. This is this type of spatial manipulation is crucial when we need to assign visual data coordinates before sending commands to a mechanical system. So let's see. You can see here is the image rotated 45 degrees, and here's the original, but it's smaller than the previous one. So yeah, you can see here is more pixelated the image than the previous. So you can see here also we have our all values or of RGB pixel. So let's go to the next one. So finally, in third housing, we compare two methods of binary and image to pure black and white, known as thresholding. A simple global threshold applies one strict numerical limit to the entire matrix, which often fails if the lining is uneven. To fix this, we use adaptive thresholding. This algorithm dynamically calculates the threshold for small loca, localized regions, allowing us to extract perfect edges and contours even when the image has heavy shadows. So let's see how well our Zorrito looks like. And here we have the home run simple, the original, and the adaptive one. So, by mastering color spaces, we have fine transformations and adaptive thresholding, we can now successfully isolate and track physical objects in real world. So let's see a little bit of the chapter 6 with my teammate Isaac, my Isaac Ramirez.
We're going to talk about the chapter 6. First, we learn how to find objects using their color. Normal camera colors change a lot when there are shadows, so we use a special color model called HSB. This helps the computer to see only the color blue and turn the background black. Second, we learn how to change the size of a picture. We also learn how to rotate the picture using math. Third, we changed a picture to only pure black and white. This is called thresholding. We use a smart tool called adaptive threshold. It helps the computer to find the edges of and shapes of an object. And if the room is dark, these tools are very important. They help our camera to understand exactly what is looking at. And that's all. Thank you.